So, in this lecture we will discuss about the context free language and context free grammar. Earlier we have seen that the regular languages, and also from the Chomsky hierarchy we have seen that the regular languages are context free languages also, but all the context free languages are not regular. How to identify a language is a context free or regular? So, whatever language we get, we have to first identify that whether the left hand side is variable or not. If the left hand side is variable and right hand side is the sentential form, then we can easily identify that that language is a context free language. But whether it is a regular or not, that can be identified if I can construct either regular expression or DFA or NFA, whatever it may be. Another way to prove that a language is regular or not, that is the pumping lemma. Through pumping lemma also we can prove it. Now, the formal definition of context free grammar is a grammar is said to be a context free grammar if it has the production of the form a to x, where a belongs to variable and x belongs to variable union terminal symbol star. So, where v equal to variable and t is terminals. It is basically the left hand side must consist of the variable and right hand side is the combination of variable and terminal symbol, or it may not be there if it is lambda present over there. So, means that the left hand side may consist of the sentential form also, then it is said to be a context free grammar. Now, let us see an example. Suppose if I write S2 ASB slash lambda. Another language I am writing S2, suppose AA, then A2 AA slash lambda. Suppose I am not considering this one for the time being. Then another language S2 AA, then S2 AA slash lambda. Now consider this language. Consider this these two productions S2A and S2A to lambda. Obviously, this one is the context free grammar, right? Because the left hand side is the variable and right hand side is the combination of variable and terminal symbol. Now, what is the language generated from this grammar? So, that case I have to derivate it, and I have to check that what are the production. It is what are the strings it is generating out of this grammar. So, initially if I replace this A with AAA, then again if I replace triple A, now if I want to stop this one, then I can stop it using lambda. So for one replacement I am getting a single A, next replacement I am getting 2A, then 3A, then 4A. In this way it is expanding. So, as a whole, can I write it as LG equal to AN, n greater than equal to 0 for this production. Similarly, for this production also, if you check, you will find out the same thing. Sorry, triple A, then lambda. Then LG equal to, the same way I can say that it must be AN where n greater than equal to 0. Now, what I want to show it to you from these two productions, that the two production is written they are equivalent. Basically, they are producing the same language, that is n greater than equal to 0, but in first set of production, that is the context free grammar, the replacement is starting from the left hand side always, and the next production of the grammar, the replacement is always starting from the right hand side. So this one, the first one, it is told that the replacement is always starting from the left hand side, it is called leftmost derivation, and in this case the replacement is always starting from the right hand side. So this one is called rightmost derivation. So in context free grammar, I have to check that in my grammar whether the replacement is starting from the left hand side or from the right hand side. If the replacement is starting from the left hand side, then these types of grammars are called left linear grammar. And if the replacement is always starting from the right hand side, then it is called right linear grammar. Now, is it so that every time a context free grammar will be either left linear or right linear? No, not like that. Suppose if I give another example, suppose S2 SS, then S2 ASB / lambda. So this one is also a context free. Whether it is regular or not, that we have to check it after finding out the DFA or the regular expression. Now I am not going into that. I just wanted to check that whether the replacement is starting from the left hand side or the right hand side, whether it is left linear or right linear. So in this case, you will find out that the replacement either can start from the left hand side or from the right hand side itself. And the next one, the replacement is not starting neither from the left hand side or not from the right hand side. So in such cases, the what type of grammar it should be, left linear or right linear? The answer is that it's a non-linear grammar, because the replacement may start from the left hand side or right hand side, both cases, or the replacement is not starting from the left hand side or not from the right hand side. So these two are example of non-linear grammar. Now I can say that case a context free grammar two part, one is linear grammar, another is non-linear grammar. And linear grammar is of two types. One is called left linear grammar, another is right linear grammar. Now we have to check that whether in a context free grammar whether it is a linear or non-linear. If it is a non-linear, then it will create ambiguity, that we will show you later on. Now we have to remove the ambiguity in such cases. So removal of ambiguity is very much important. So non-linear grammars are ambiguous. Now the way what is derivation? Next we have to check that what is derivation. Derivation basically we are doing from the beginning when we are doing that from the regular language or the and the formal languages also. So in such cases also every time we are we are using the derivation. Derivation is basically if a production rule is given to you, and from that production rule, from the start symbol, how you are achieving the sentences, that means the string, by replacing one by one step. Again I am replacing this S, triple A, triple B, then replacing this S with lambda, I am getting lambda, then BBB. So ultimately the resultant string is this one, right? So the derivation is the step by step process through which I am achieving the sentence from or the string from the start symbol, and it is represented by this arrow. Now there is another way of seeing the derivation also. The second way of seeing the derivation is called the derivation tree, which is an order tree. So a second way or an alternative way of showing derivations independent of the order in which productions are being used is by derivation tree. A derivation tree is an order tree in which nodes are labeled with left hand side of the production and child nodes are labeled with right hand side of the production. So let us see through an example. Suppose for this particular production rule, and how we are making the derivation S to ASB, then AASBB, then triple AS triple B, then S is lambda, right? Now as we have already told, the derivation tree is an order tree where the left hand side will be the node, will be labeled as a node, and the right hand side will be labeled as the child of this node. So I can write it like this. So arrow will not be there. Again this S is being replaced by again ASB, so I can write it like this. Then this S will be replaced by ASB, then ultimately this S is replaced by lambda. So this is the ultimate derivation tree, which is an first thing is that it's an order tree. Next thing is that the left hand side is replaced with the which is represented by the child node of that particular node S, and again the right hand side of this particular node S, and again the right hand side, and if you say then this S is again replaced by this A, S and B. Now, if I consider this portion, then I will say that this one is the intermediate portions of the tree. Now, in the intermediate portions of the tree, if we find out that all the nodes are node contains variable, then it will be called an incomplete derivation tree. And if after getting all the nodes and its child node, when we reach to the leaf node, and if we find out in the leaf node that all the leaf node must be of terminals. If it is terminals, then we can say that it is a complete derivation tree. If the leaf node consists of the non-terminals like the S, then it should be becomes a complete derivation tree. So, in this case, if you check this leaf node, you will find out that capital S is along with this small a and small b. So, it is an incomplete derivation tree. So, what are the properties of a derivation tree? Let us see that one. Every leaf is labeled from T union lambda. Has no siblings labeled with V union T union lambda, then that tree is called incomplete derivation tree. Obviously, it should be incomplete derivation tree. So, the first thing is that the root is labeled with S, every leaf is labeled with T union, every leaf is labeled with T union lambda, every interior vertex which is not a leaf node has a label from V, and a leaf node labeled with lambda has no siblings. If a leaf node labeled with V union T union lambda, then that tree is called incomplete derivation tree. So, obviously, that must be that should be an incomplete derivation tree. Now, let us see an example through an example, then it will be little bit more clear. So, suppose if I write S equal to A B, then A to B capital B small b, then B to A, then lambda. Now you are asked to either in the exam what they will do, that they will ask you to find out a particular string using a derivation tree. Suppose in this case derive, you are asked to derive this string A4B using, I must draw it in the next page, sorry. Derive A4B from the following grammar using derivation tree. Now my grammar is S to AAB, A to B, 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 B to A, then slash lambda. Now my ultimate goal is to find it out, that S to ABB, right? This is question number 1. Now start it with the derivation tree. Now as obviously, first of all check that whether the grammar is a left linear grammar or non-linear grammar. As it consists of look at this one is must be non-linear one, because capital A and capital B is there. Either I can start from the leftmost side, or either I can start from the rightmost side, and in this case neither I can start from the left hand side or right hand side. So both of these grammars are called non-linear one, right? Now AAB is there. Now again replace this capital A with B, capital B and small b. Then how many B I got? Again I can replace this B with small b, capital B and small b, and then this B with lambda and this B also with lambda. So this is one of the derivation tree that I can form. Now try to, and after that how to get the strings out of this derivation tree. In that case you have to scan it from the leftmost side, and whatever the leaf node value you are getting, just write it one by one. So I am getting A, then B, then lambda, then B, then lambda, then B. Sorry, 2 B's are there. So if I write it down after removing the lambda, then I will get A4B. So from this grammar, what is been asked from the question, that to derive the strings from this derivation tree. So I got it. Now let us try that whether is any other tree is being possible or not from this grammar. Now what I will do, that I will replace this B with B, B and B, and replace this S with this A with, sorry, I made a mistake. I have to remove this one. Let us remove this one. Okay, fine. From this A I am doing B, capital B, and then small, it should be small b. It must be small b. Okay, fine. And this B is again A, and this A will be again replaced by B, capital B, then small b, and then this B will be lambda, this B will be lambda. So I got another derivation tree. Now if I scan to get all the strings from the left or from the leaf node, I will get A, B, lambda B, then lambda B. So if I write it down, then what else I will get? A B, lambda B, lambda B. I think one B. This B I missed it down. So it should be A B lambda, then B B lambda B. So if I remove the lambda, then it will become A B B B B. So A4B. Now the moral of the story is that I have been given one grammar and I have been given one string. Now that string can be formed by two different derivation tree. The same string I am getting from the two different derivation tree. If such kind of things happens, then these types of grammars are called ambiguous grammar. Ambiguous grammars are those grammars those grammars that forms more than one derivation tree for the same string, for the same string. Now another notable thing is that as we find out earlier that this grammar is a linear grammar also. So already we have told earlier that all the non-linear grammar. So all the non-linear grammars are ambiguous. So why ambiguity is dangerous for the compiler design and also any programming language design. So we will discuss it later, but first we have to check that whether that particular grammar is ambiguous or not. So let us see with another example that will clear our concept. Now let us see the next example, that whether this one is ambiguous or not. Show a derivation tree AA4B with the grammar now S2. Oh, I have to use derivation tree, right? Sorry for that. S2 A and B. What is my motto is to find out A8 4B. So if I replace this A with B, then this B again with S and B, this S again with AB. So I don't have space, so what should I do? Let us start it from here itself, because it may take some space. S2 AB, then A2 small a capital B, then this B to S and small b, this S is again A, capital B, then A2 small a, then B. Now what should I do with this B again? So if I replace this b with sb, then multiple numbers of b will come. Okay, I need the b, actually multiple numbers of b. 2a I got, now I need multiple numbers of b. So from this I am getting s and b. This s will be replaced by lambda, this s will be again replaced by lambda. So 2a I got, 2b I got, I need another b, and that another b, that I can get it from here itself. Okay, now if I make a scanning from the left hand side, a, then lambda, b, lambda, b, b, lambda, b. So what are the strings I am getting? Let us chalk it down. A, lambda, b, b, lambda, then b. So ultimately I am getting double A and 4b. So this is one of the way of deriving this string. Now let us try to find out, is there any other equivalent tree is possible or not. Now again start with s2, what is my string? s2ab, right? s2ab. Now in such case I will replace this s with again s and small b. Replace this s with small b, fine. Then this s will again become ab, sorry, again become capital A, then capital B. Then this one again will s and small b. Now this a I am getting it as ab, right? This a I am getting it as ab, and this b will again become this b will again become capital S small b, and this s will again become a capital B, and this b will be s and then small b. Then this s will be this s again, okay fine, this s will be lambda, this s will be lambda, and this s will be again lambda, then s a small b. Okay, no, I am not going to get it down. No, it is not possible, it is not possible in such cases. So this one is not possible. So here look at this, after getting a lambda I am getting b again. So the multiple numbers of trees for the same productions is not possible in this case. So it is not possible. So this one is not ambiguous, this one is not ambiguous. So you have to check it down whether ambiguity is possible for this language or not. Now let us see another example. Sometimes the strings will not be given to you and you will be asked to find out the ambiguity of the grammar. So suppose in this case one example is given, q2, sorry, it's q3, s2, asb, ss, then lambda, and then bsa. So proof whether the grammar is ambiguous or not. Proof whether the grammar is ambiguous or not. So s2 asb, then again I have s and then s. This s I am putting it suppose asb, and this s I am putting it suppose bsa, and then this s is lambda, this s is lambda. So if I scan it, I will get aa lambda bb lambda ab, means aa bb ab. Okay, now let us check that this production is possible for not. This string is possible for not s to ss. Then I need what, I am putting it over here, s to asb, then again s to asb over here, and I got abb. Next what I need, that is abb, then ab again, right? So this s to asb and this s to lambda. Now if I scan it, this s should be lambda, bb ab. So I am getting aa lambda bb a lambda p. Look at this, same production, same string I am getting over here with the two different tree. So if two different trees are possible, so this one is ambiguous. So you have to check in this way that whether a production is ambiguous or not, and obviously by checking the question itself you can figure it out initially that whether the grammar is ambiguous grammar or not. In this case it is obviously an ambiguous grammar. Now let us check that another example. So proof that whether it is ambiguous or not. Now let us start arbitrarily as bs. Okay, fine. Now start with this s, b, s, a, s, and this one as a, s, b, s. Now stop all the s with lambda, right? Stop all the s with lambda. Then what should I get? It becomes ab, a lambda, b lambda, lambda, b lambda. Now I should get ab, a lambda, b lambda, a lambda, b lambda. Again let us check, a, b, a lambda, b, then lambda, a lambda, b lambda. Okay, so if I remove the lambda, then I should get a b, a b, a b. So this string I must get. Now let us check that is there any other derivation tree that possible from the same grammar or not. So I am starting with s to a, s, b, s. Okay, now I got ab, fine. Then start it down in this one, a, s, then p, s. Then start with this one, a, s, b, then s. Now replace this one is ab, this one, okay, it is not possible over here, so it should not be there, it should not be there, it should not be there. I have to replace this one, I have to replace this one or this one. This one I can do one thing, that I can replace it with b, s, a, then s. Then I will get AB, then AB, okay, then AB, okay, fine. Then this S will be replaced by lambda, this S will be replaced by lambda, this S will be replaced by lambda, this S will be replaced by lambda. Now scan it from left hand side. Now what else you will get? What are the strings you will get? A lambda, AB, lambda, A lambda, B lambda. Now remove all the lambda from here. So sorry, I missed the b over here. So b is there. So a b, AB, right? So same strings I am getting, but with some different derivation tree. So I can say that this one is also ambiguous. Now, why we are solving so much problems on ambiguity? Because ambiguity, checking the ambiguity and removing the ambiguity is very important in case of compiler design. I am showing you one last example through which it will be clear why ambiguity is removing ambiguity is very much required. Consider this example: E to E plus E, E to E star E, and E is 0, 1, 2, 3, 4, 5 up to ... 9. Now obviously this language E is an expression, basically it is an arithmetic expression. So this example, obviously the first production and the second production is a non-linear production or non-linear grammar, because I can start the replacement either from the left hand side or from the right hand side, any one of them, right? Now you are asked to derivate 9 into 7 plus 2. You are asked to derivate 9 into 7 plus 2 using derivation tree. So that case what we will do, E will be replaced by E plus E, right? Then this E will be replaced by E star E, then this E will be replaced by 9, this E will be replaced by 7, this E will be replaced by 2. Then if you scan it, you will get 9 star 7 2, then 9 into star into 7 into 2. Fine. Now let us try another way of finding out the derivation tree. Instead of starting with E plus E, I am starting it with E star E. Okay. Now this E will be replaced by E plus E. This E will be replaced by 9. This one is 7. This one is 2. Now if we scan it, then it becomes 9 into 7 plus 2. So same expression I am getting, but two different derivation tree. Now why it is dangerous? Now if you want to evaluate it from the first expression, then from the evaluation what the values you are getting, because you have to make the multiplication first, you have to do the multiplication operation first, then it will be 9 into 7 is 63, 63 plus 2, that should be 65, and in the second operation first you have to do the addition, that means 7 plus 2, that is 9, 9 into 9, that should be 81, right? So the same expression is there, and we are evaluating that same expression using two different derivation tree. We are getting two different results. Now which one is correct? Obviously the first one is correct, but how your machine will come to know, your compiler will come to know, because you will write the code during the compiler design for the same expression, how to evaluate the same expression using a context free grammars. Now if you write the context free grammar, the machine will understand the second one and it will give you the result which is not the intention of the programmer. So that is why ambiguity is very dangerous for a at the time of designing a compiler. So first of all we have to remove the ambiguity first.